right, this is more factoring. As you'll notice from your review assignment that most of your test is factoring, okay? Elizabeth, you can just watch and then just watch the video tonight and copy it at your leisure, okay? I just want to make sure that you understand. Tonight's homework is page 463. You're going to do numbers number 19 through 30. I'm waiting for corner seats to move, please. Mina, can you see? All right. Well, the first thing that we need to go over is something called the remainder theorem. And a beautiful thing about the remainder theorem is that we can use synthetic division to find points on my polynomial. Let me show you what I mean. Let's say we have f of x is equal to x squared plus 2x plus 1. Let's do something real simple. If you're in seat A, I would like for you to plug in 0. If you're in seat B, I would like for you to plug in 1. If you're in seat C, I would like for you to plug in 2. And if you're in seat D, I would like for you to plug in -2. Do that right now, please, and then share your answers when I ask you. Destiny, what letter are you? D. D as in dog? B. B as in boy? Yeah. What happens when you plug in 1? So you plug in 1 here, that's 1 plus 2 plus 1. Okay, so you should get a 4. Sean, what letter are you? Okay, what'd you get when you plug in 0? Yep. Dylan, what letter are you? Jarrell, what letter are you? Sophia, what letter are you? D as in dog? Okay, what happens when you plug in -2, Ben? -1? What'd you guys get over here for letter D? 1? -7. Kanoa, what letter are you? Mia, what letter are you, babe? D as in dog? What'd you get, babe? Negative what? It's okay, babe. We're all checking. We're all just making sure we get it together. What'd you get, babe? Oh, you accidentally did C. Oh, who's my D in letter 8? In group 8. Hi, baby girl. What'd you get? What'd you get, Jess? For letter D or letter C? D, you got 1? Yeah. Okay, let's all do letter D together. How about that? Everybody plug in -2. Ooh, we have 31 flavors up in here. Jerome, what'd your group get?
Yeah, I said 1.
Aldo, what'd your group get? Angelo, what'd your group get? 1. All right, the answer is 1. When you plug in -2 here, that becomes a +4. And a -2 times a +2, that's a -4. That's going to cancel and you're just left with 1. Okay, Caesar? So when you guys put on the calculator, some of you guys are so dependent on your calculators, and your calculators are like fake friends sometimes, okay? They're going to let you down. Because sometimes that calculator doesn't understand that you're trying to square the whole -2. So you guys have to do it manually, oftentimes manually, okay? All right, Mia, when you plugged in 2, what'd you get? All right. So now, what I want to teach you about the remainder theorem is had I used synthetic division for these bad boys, the remainder is going to give me that same answer. So what I want to do is plug in 0 with the coefficients of 1, 2, and 1. And let me show you what happens. Ma. Remember, drop it down and just multiply and add? Remember that? Whoa, remember that?
Yeah.
Scaring me. Ready? Bring down the 1. 1 times 0 is just 0. 2 times 0 is just 0. 2 times 0 is 0. That's okay, babe. And then you're left with this 1. This remainder right here is the same thing as that 1. Let me prove it to you again. Plug in 1 into synthetic division with the coefficients of 1, 2, and 1. Look what happens. What should I get here? According to my theory, what should happen? What should be the remainder? 4. Let's see if it's true. Bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is, and look, don't you get 4? Let's do it again. Synthetic division again. If I do synthetic division with 2, and the coefficients are 1, 2, and 1, the remainder is also going to be that value. Bring down the 1. 1 times 2 is 2. This becomes a 4. 4 times 2 is 8. And then I get a 9. So people oftentimes, instead of plugging into the function that 90% of us got different answers, what's easier way instead of plugging into the function? What could you do? Synthetic division. Because the remainder is going to give you the points as well. Y'all with me? So the last one, which was -2, which is the one we couldn't agree on, a good way to check it is by using synthetic division. So if I put in 1, 2, and 1, drop it, that's 1. 1 times -2 is -2. This becomes a 0, 0. And again, my remainder is 1. So I know that it should be a 1. So now, either through substitution by plugging in the numbers or with synthetic division, I was able to concur that 4 points on this parabola are 0, 1, 1, 4, 2, 9, and -2, 1. I know that all 4 of those points pass through my parabola. In summary, what I want to write down at the very bottom, and please put this as your most important piece, the remainder in synthetic division corresponds to the y value to the x value given. So now I have an extra tool to help me find points on my polynomial. So for those of us who retook the chapter test and we saw that we messed up on plotting points for the cubic, now we have an extra tool to make sure that we did it right. Now instead of plotting points by plugging into the equation where we might be making mistakes and depending on the calculator, I'm just going to use synthetic division. How many of you guys actually like using synthetic division? You got to that point. Good. Synthetic division, if you notice, 90% of your mistakes are eliminated. Did you guys notice that? Now, where do my rookies make a mistake? Real simple. Some people forget that you have to go in order. Sean, can you listen to me? So some people will see like an x cubed and then forget an x squared. They have to insert the 0. So that's the only time people mess up when they use synthetic division, is they actually didn't use the synthetic division correctly. But 90% of my time, my kids, when they start using synthetic more often, much, much, much less mistakes. Okay? All right, let me give you a doyo, actually. I want you to find me f of 3 for this function. Old school way, you used to plug in 3. Now I'm telling you to find the easier way to do this. So what goes on the side? What's in front of x to the 4th? What's in front of x cubed? Good, 3. What's in front of x squared? What's in front of x? What's in front of x? Ready? X4, x cubed, x squared. What's in front of x? 0. And then what's the constant? You sure? Okay, that's what I meant to tell you guys. If anybody messes up it's on synthetic, it's because they forget stuff like this. This is in front of the x to the fourth, x cubed, x squared, x, and then the constant. Drop it down, that's a 1. 1 times 3 is 3. 3 and 3 is 6. 6 and 3 is 18. Negative 15 and 18, that's going to be 3. 3 and 3 is 9. That's 9. That's 27. That makes that 57. What did we just find, Sean? The remainder is 57, but what did we just find? The point. What is the point? Where does this polynomial pass through? Yes, very good. All right, any questions on the doyo? All right, we're going to move on to some more factoring. Like I promised you, most of your test is based on factoring. So if I have example 1, 2x to the 5th minus 8x to the 4th plus 10x cubed. The first thing I want to do is factor out the greatest common factor. So I want to know what I can divide each one of these by that they each have. So basically this guy has a 2 and it has 5 x's. That's what that means. This guy has a 2, a negative 3, and then it has 4 x's. This guy has a 2 and a 5 and it has 3 x's. That's what that means, you guys. I noticed that last week that when I was helping that some of you guys were, thank you, thank you. Some of you guys were still not grasping this point. Right in front of you, right in front of you. I got you. So that, no I don't. I went like this. So that means that I want to take out what they have in common. Okay, Jarrell, what do they each have in common? You guys let him try. What do they all have in common? Any numbers and letters that they have in common? 2. And how many letters do they have in common? Just 1? So they each only have 1 x in common? Yeah, you're right. They each have x's, but how many x's do they have in common? 2? This one has 3, this one has 3, and this one has at least 3, right? So how many do they have in common? 3 x's, okay? So basically, you guys, what I could factor out from everybody is a 2 and x cubed. I can literally take out a 2 and an x cubed from each one. And then that's what I mean by taking out your greatest common factor. Now watch. If I take out the 2x cubed, you need to be able to tell me what's left over. Samantha, what's left over if I took out a 2x cubed from here? What's left over? Very good. How about over here? Yep.
Wait, is x?
Sorry, you guys. And what's left over here, baby? Plus 5, right? Positive 5? Sean, is this bad boy factorable? Is there a number that multiplies to 5 and adds to negative 4? All right. You sure? Not even 5 and 1? 5 and 1? So then 5 and 1, which would have to be negative? The negative 5. But is negative 5 times 1 a positive 5? So does it work? No. So you were right the first time. Good job. So my final answer is just 2x cubed times x squared minus 4x plus 5. How do I make sure that I'm right, Kyle? How do I make sure I'm right? What can I do on my graphing calculator? Yes, very good. You can plug this into y1, plug this into y2, and make sure you get the same graph. If you don't have the same graph, Isaiah, what does that mean if I don't have the same graph? Isaiah, what does that mean? If I don't have the same graph, what does it mean? Correct. Good job. It is not correct. All right. Here's your doya. Try this by doing the greatest common factor. We're going to call that GCF. You always use the greatest common factor in order to simplify things. So 6xy cubed minus 14x squared y squared minus 22xy.
Wait.
Oh, I didn't do a medication. Why? Are you on medication? Painkillers? That's it?
So 2xy
You're a champ, bro.
minus 7x.
3y squared.
Yeah. 2x, y, parentheses, 3y squared minus 7x. And then a y also. And then minus 11.
Oh, you forgot a y from everything too?
All right, your greatest common factor was a 2xy. When you take out a 2, an x, and a y, you're left with 3y squared minus 7xy minus 11. Any questions on the doyo? Lauren, how we doing back there, guys? We're all right? All right. The next method that we need to go over is chunking. I know you guys saw that in your directions last week, but now I already taught you one way to do it, and now this is another method to use chunking. Mr. Riad, why you keep teaching us all these methods? Because you have to decide when it's best to use each method. Just like when you guys get a job in a couple years, if you can only do one thing in one way, you're not very useful to your boss, straight up. This is the only way I know how to do it. Well, get out, I don't need you. I need you to figure out when is the best way to do each thing. Some of you guys literally use a spoon for everything. You have one way to do something because your 6th grade teacher taught you to do it that one way, and you stuck with it for the last 5 or 6 years. Now I'm ready to give you a bunch of tools, and what makes you so marketable is the fact that you know when to use each one. That is much more useful than being able to use one tool at all times efficiently. Everybody with me? Mm-hmm. All right, so this is what chunking is. It's another method to factoring. Can you use it all the time? No. But again, the beauty of it is going to for you to decide when to use it. Here we go. Example 2. Let's say we have 4x squared plus 8x plus 3. Here is a trinomial. So back in the day, or for your homework, I would tell you to do what multiplies to 12, adds to 8, and then I would make you do the lightning bolt. Let's run through this real quick. What multiplies to 12 and adds to 8?
6.
Nicely done. You guys are much faster at this now. So that's 4x squared plus 6x plus 2x plus 3. Here I can take out a 2x, and I'm left with 2x plus 3. Here I can take out a 1. I'm left with 2x plus 3. So I know my final answer is going to be 2x plus 1 and 2x plus 3. This right here is the old school way called the lightning bolt, but that's not what they're going to call it once you're outside this classroom. This right here is called factor by grouping. So when you guys come to Our Power or leave my class next year, nobody knows lightning bolt but us. Nobody has an idea. That's my word. That's what we thought of together. Once you go to pre-cal next year or go to college next year, don't say lightning bolt. They're not gonna know what the heck you're talking about. It's called factor by grouping. Everybody with me? All right, now chunking is another method to do the same exact problem. And some people prefer it because it's much faster. Let me teach you chunking. So let's say you have 4x squared plus 8x plus 3. Well, chunking means that you recognize that this one is double that, or this one is a factor of that, excuse me. So what happens is you just create these parentheses and you tell yourself, okay, in these parentheses right here, what number times itself gives you 4x squared? 2x, very good. So I know that this bad boy right here is going to have a 2x squared in here. So whatever you put in here, you put right here. And then you just have to ask yourself, 2x times what gives me 8x? 4, right? So all I have to do is now bring down this 4. The first time I do this is going to feel very foreign, so just walk with me on this, okay? So what is the first thing I did with this first parenthesis? What did I find?
How it equals to 4x
Yes,
squared.
what I squared to get me that 4x squared. Everybody with me? Then what did I do to the second parenthesis?
To see how it equals to 8x.
So I just copied that 2x, and then I figured out how did I get from 2x to 8x? Well, I had to multiply it by 4. Everybody with me? All right, so the next line says 2x squared plus 4 times 2x plus 3. Are you in agreement that these two lines are saying the same thing? This is the same as this. Are you in agreement? Yay or nay? All right. So instead of putting a 2x, I'm going to make up a letter. And you know what letter we really love in math that represents everything? But we can't use x because we already use x. What's the next best letter? Y is actually not it. Do you guys know what we always use? A, yes. We love A. A squared plus 4a plus 3. So instead of the green parts, you just put a, and then you just factor that. Isn't that super easy to factor? What multiplies 3 and adds to 4? Yeah, 3 and 1. So a plus 1 and a plus 3. But what is a? You just substituted a. Instead of a, what did you change the a to be? 2x. So your final answer is 2x plus 1 and 2x plus 3. Look at that. Isn't that what we got up here? You guys see how we get the same thing? I don't expect you to be convinced yet, but I'm going to do another one with you, and then I'll give you a doyo, and you'll see the pattern. Yes, babe?
Do you have to change the a to whatever you put in the bracket?
Yes. That way it's easier to factor. And then you just put it in later. What you're doing, Liz, is you're saying, I don't want to deal with these two x's. I'm just going to make it a whole letter by itself. So instead of 2x, I'm just going to call it a. Then I'm going to figure it out. Then I'll just put it back when I'm done. That's what you're doing.
Why did we do what? We just left 4a by itself. Like,
Isn't 2x a?
yeah.
I substituted 2x. I don't want to deal with the 2x. I'm just going to call it one letter. We just called it a.
Oh.
So we substituted 2x for a. Instead of saying, I don't want to deal with 2x, so just call it a. Factor it. Then when you're all done, just put the 2x back. You see it? You see how this is a plus 1? But instead of a, what is a? So just put it back when you're done. That's all it means. Yeah? So a lot of people like it. Excuse me. A lot of people like chunking because it's faster. Let's try example 3, and then you guys can try to do it. $25x squared plus 35x minus 30. I'm going to try chunking. The next example I'm going to give you is an example of where chunking is not going to work. But let's try it for this one. Is there a number that multiplies to get me 25x squared? What is that? 5x. Very good. So that's my 5x. Copy down that same 5x right here. So what number times 5x gives me 35x? 7. So So put a plus and a 7 minus 30. But instead of 5x, can I use an easier letter? What should I use? Let's use a. So instead of 5x squared, what should I write? A squared plus 7a minus 30. What multiplies to negative 30 but adds 7?
Five.
What? Why?
10 agree. 10 agree.
Oh yeah, you're right.
Do you know the answer?
10
Negative, positive,
Positive 10 and negative 3.
positive 10, and negative 3. You see his or her? Alright, cool. Kathleen, how are you doing back there? But is the answers with A's or the answers with X's?
X's.
So when you're done, instead of leaving the A's, what are you going to do?
5x plus 10.
5x plus 10 and
5x.
5x minus 3. Do you see why people like chunking now? Instead of having to do a lightning bolt and finding the greatest common factor and all that. You see it? Alright, let me give you a doyo. Try it on your own. Hi, sweetheart. Yeah, come save my life, babe. Can you make this work? Thank you. 49x squared plus 60. Babe, I don't know anything. I don't know anything. Look, the remote's right there, and that's all I know. God be with you. I know, Jashawn can help you too, but after the doyo. To do the doyo and then help him, yeah? Liz, what do we do first, babe? Mm-hmm. And then what goes outside here? Mm-hmm. Blame it on the time. Yeah, babe. All right, now what, babe? Six and 3, good. Oh, you guys about to have a factoring test. This is ridiculous. And then what?
And then you switch the A back to 7x and 7x plus 6 and then 7x.
All right. Much like you won't eat cereal, you guys, eyes on me. Much like eating cereal with a knife won't work, sometimes chunking won't work. Okay? Who eats cereal with a knife? Anybody? I will pray for you. Doesn't work. Like, you might get one little Cheerio on the knife and you would still be eating breakfast right now.
It's lowercase d with exclamation point.
All right. So let me show you when chunking does not work. And then I have one more thing to show you guys. So chunking does not always work.
So did I, but I don't care, so I don't remember.
Dylan, can you share with the class why chunking would not work for this?
It's not a perfect square.
Yes, 10x squared is not even a square. So, how? Y'all with me? So chunking is great when it works. Otherwise, you have to know when it works and when it doesn't. So you're not going to be able to use it for this example. All right, example 4 is called the quadratic form method. So we've just been over 3 methods now. We did review this last week. Maybe 80% of you actually got it, so I'm teaching it again. 80% is not good enough for me. Riad's not an 80% teacher, so I want to make sure we're all at the same page. So if I give you x to the 4th minus 7x squared plus 10. Let's rewind. What if this said x squared minus 7x plus 10? How would you factor this? x minus 5, and x minus 2. What is x times x? X squared. And then you have a negative 5x and a negative 2x and a positive 10. Do you guys see how the middle term is just the first one by itself? So if this is x, the middle term is an x. Everybody with me? Did I lose anybody there? All right, so now apply your knowledge to, now you know if the first term is x to the fourth and the middle term is x squared. Apply your knowledge to what we just did here. So x to the fourth, instead of x squared, I got x minus 5 and x minus 2. So instead of just being regular x's here, like this middle term, these are going to be this middle term, which is
Negative 7x squared.
x squared, okay? So how would I factor x to the fourth minus 7x squared plus 10? Instead of x minus 5, what is it going to say this time? X squared minus 5. And instead of saying x minus 2, what is it going to say? X squared minus 2. And that's what's called quadratic form. For those of you guys who like the box method, I want to show you what that looks like in a box. Look at this. X times x is x squared. X's is my middle terms, and I get a 10 here, so that's why it's x in the middle term, because negative 5x and negative 2x is negative 7x. Same thing if I put an x squared minus 5 and x squared minus 2. X squared times x squared is x to the fourth. Negative 5x squared and a negative 2x squared is a negative 7x squared. The reason why it's called quadratic form is because it is the same form as a quadratic except different middle terms. Everybody with me? Questions on quadratic form? How are we feeling, Samantha? We're okay? So let's do a couple of examples together. Example 5. How would you factor x to the fourth x to the fourth minus 13x squared plus 42? What's the middle term?
13x.
No, what? Yeah,
Oh,
negative
x
13x squared. So what is going to be here? X squared and x squared. Very good. 1 multiplies to 42 and adds to negative 13.
7 and 6.
Negative 6 and negative 7. As Kyle has said about 15 times, how can you check if you're right? Plug it into your calculators. This is your y1, this is your y2, and you better get the same graph. Here's your doyo. X to the 10th plus 20x to the 5th plus 100. Michaela, what'd your group get? Plus what? And then? What were you just saying is your answer? Go ahead, Viv. You had it right. Very good. What do you guys think? Pretty doable? All right, when does this not work? Again, this is called quadratic form. When does it not work? Be ready to tell me why it wouldn't work for this example. Jessica, why won't quadratic form work for this one? Okay, that's a great explanation. That's one good reason. Remember, this had to be divisible by 2? What do you mean, Miss Riad? Here's your 10. You divided it by 2, which happened to be the middle term, right? What's another explanation? Ready?
X to the 6th, when you put it for the a value in the beginning, when you add both of them up, it will give you x to the 9.
So if you have x to the 6th times x to the 6th, does that equal x to the 9th? No. So this quadratic form won't work for this. All right, we went over 3 forms, Kathleen. What was the first form we went over? So yes, the first thing we did was the remainder theorem, but that's not a factoring form, right? So the first form we went over was what? Chunking. Be ready in your summary to tell me, in your summaries, what chunking is and when to use it. What's the second form, Angela? Quadratic form. And then the third one I need you to talk about is the remainder theorem. But it's not a factoring form. All right, write your summaries right now, please.